Welcome everybody out to another video for Lean Tact, and we're going to share today how tact planning and work packaging can really optimize your project. So seeing the math could be something that's really fun. Stay with us because you're going to enjoy this. I'm showing here a regular tact template that we have that you can download from our website at leantact.com. And obviously you probably know where you're going because you referenced the content, but this has our normal tabs in here. But in the norm level schedule, we have some examples of a project where we did an optimization. So this little section right here really has nothing to do with the dates above. I was just showing this visually for you so you can see that when you have a sequence, you can plug in that sequence as shown here to the left, and then identify the durations, and then package that into a standard tact time. Now, that training and how to do it and how to use the numbers down here, we teach that in our lean tact courses, in our fundamentals and our advanced courses. So please consider signing up when and if you no, let me say it like this: when you are ready to learn that. But the bottom line is when you package these activities together, you will come up with a legend, which is your legend of tact wagons. So these tact wagons will go into the creation of a tact plan. And so here we have down here shown at a 3-day tact time, we have the tact wagons, and you'll see the 3-day stagger all the way down with 4 buffer days. Now, I'm going to show you some really nifty, that's something my dad would say, but I'm going to show you some really cool math. And we've plugged it in here based on the formula tact wagons plus tact zones minus 1 multiplied by the tact time equals the duration. That's the math. That's Luhey and Binninger's law that is associated with Little's law that allows us to calculate information based on a schedule. So this top line right here was what we came up with from the pull plan, from coordination with trades, that we would have 8 tact wagons, which are these individual boxes here, or you could call them box cars, 5 tact zones, and then minus 1 multiplied by a tact time of 3 equals a duration of 36. So then we are able to calculate some other information of how many days per trade, meaning how many days does this one tact wagon, the initial one, surface work, get on the project? Well, it's 15 days. And what's the square footage? And what's the efficiency parametric number? So then using the formula, we run down the simulations based on smaller batch sizes, smaller tact zones. And the math will, to a certain extent, there's a little bit of formatting, but the math here will auto-calculate and give you the information. So again, we have the tact wagons and the tact zones minus 1, and then the tact time in decimal, and this is where we actually calculate the probable tact time rounded. And then it auto-calculates the duration, the time per trade, the square footage that we're now dealing with, and the efficiency parametric number. Now, the best way to identify, should I go from 5 areas to more areas, or in the other direction as well, is the process of elimination. If you read the book Tact, or what's it called? The Tact Production System, or Tact Planning and Integrated Control, about the tact production system, you'll know that there's what's called the efficiency parametric, and that we don't allow anything over 3 or under 0.3. So these are automatically redded out. We asked the superintendent on this project for interiors for a medical office building, what's the smallest area you and your trades are willing to spool or prefabricate areas? And they're like, the feedback we got was 2,500 square feet. So great, redded all those out. For the duration, the original schedule that we had promised with trade partners with the sequence was 36 days. So I can't agree to a 90 or 39 or a 38 or a 40, so I read those out. Okay, then the time per square footage, or no, time per trade, sorry, not square footage, time per trade, I had agreed in this sequence to give the trades at least 15 days per phase. So I obviously can't agree to the 14 and the 14, so I read those out. So legitimately, the only options we have are 8 tact wagons and 5 tact zones, 8 tacked wagons and 8 tacked zones, 8 tacked wagons and 9 tacked zones. And so when you look at that, then you can come over here and look at the data. Now, first of all, a 1-to-1 ratio for an efficiency parametric is pretty good. So we really like that. The square footages will have a bearing. Do we want to go down to 27 uh, or 2,800 square feet, or do we not? What's more important, the duration here or the amount of time each trade partner has? Either way, you're able to analyze it based on data. And so for this one, we had chosen 8 tax zones as our most probable scenario. Now, what happens is we're able to simulate what 8 tax zones would look like, and you can see that it's faster. As long as you can accomplish it, it's faster, and you have the same amount of manpower. You actually have more time, so you actually could have less manpower, less materials, and it's really structured in a nice flow. But the main thing is we gain back these buffer days. So instead of just 4 buffer days, we have an additional 2. We're able to put 2 in the actual sequence, and then we have 2 tack time buffer days. Now, why is that important? The reason it's important is because no schedule should ever have a critical path. You should have buffers in the system so that when a delay happens, let's say a delay happens right here, and I know I've shown this to you before, you can either move that one area or you can move the entire thing and eat into these buffers as a system. Every project has problems. Every project is going to need these, and TAC planning with Last Planner and Scrum is the only system that will build buffers in based on an optimization and allow you the capacity to absorb them, because you will have material interruptions, you will have RFIs, you will have quality defects, you will have problems. And how are you going to deal with those problems? If you're dealing with a critical path, you're already behind schedule. So this is the really cool neatness, niftiness, awesomeness of what the formula will allow you to do to analyze what are the right batch sizes according to Little's law, and it really puts the power back in your hands. Now, you're not going to do this for every little area on site, but you'll do this for interiors, for exterior, for superstructure, for the basement, for key sequences, and it's very, very easy. Even though it might look intimidating, it's very, very easy. And so what I really want to say is that the message here is that tact planning gives you the ability to optimize and gain back buffers so that you can absorb the interruptions that will happen in construction. No project should ever have a critical path.